Okay, thank you. Yeah, I forgot the title from the title slide, but also from there. So it's a mixed reality for operating mobile machines is the full title of the project. We call it Miro for short, and it's a Business Finland funded research to business project, very similar to what was in the previous presentation, one of the projects, and it kind of started from various different projects that we did for the from the request of the local work machine community. So some just a brief look at what we did before and how did this lead to doing a commercialization project on the same idea or similar topics. So the kind of the first dip into this area was we had this digital C2 structures for work machines, short C-work, 2016, where we were trying to solve this issue that you have these massive buckets and booms and things which are really kind of blocking the view, so you don't see what you're doing. And here's a very extreme example of the operator not really seeing that they're about to crush our little test dummy there. So here our solution to this was based on 3D sensing of the environment, and then windshield projection and the calibration of all these items together, so you can effectively see through this, kind of virtually see through the bucket. So basically you see what you're going to bump into. Then from there, we moved on to remote operation. We tested several use cases, forest harvester booms, forest the harbor logistics, container cranes, armored personnel carriers. There's some YouTube videos about that on the Civit channel, with a kind of a very similar idea that we 3D reconstruct the environment. We see what kind of information we can extract from it that would help the operator to perform better. For instance, we can identify tree trunks for the operator to grab onto and or indicate where the load is going to drop if they now release the gripper, or how far they should be pushing their boom to reach the target that they're going for. So these ideas were kind of successfully implemented as prototypes, successfully reported to the funding agency, and then kind of left there. So then we thought that, okay, let's try to do something a bit more with these things. So we went for the research to business project, and we're running it until yesterday when it ended. And our kind of sales pitch was the critical visibility issues in mobile work machines. So you're here kind of combining the previous project work. So we had the visual obstructions for the local operator. You still have the boom and the bucket and all kinds of things in front of you. Or then we can consider the case where you are not there at all, so you really have a critical visibility issue there, because everything that is coming from the work machine needs to be conveyed over streams, basically. And they have slightly different problems or the symptoms, but they all lead to the same outcome. So basically your productivity is low, you work slower, you can hurt people, you can hurt property, and this all costs. Also, it's not nice to hit people. And very similarly to the other earlier projects, our kind of concept starts with the 3D sensing. So we try to understand what's going around in the around the machine. Then we have to stream it. So we have to be able to effectively stuff all that data through some kind of a limited bandwidth network. And then on the receiving side, to be able to show all that data in a way that doesn't actually kind of overload the operator. so that they would still have a kind of a natural and pleasant working environment. And we are coming from the signal processing side, so we do algorithms, we do software. For all the, let's say, network needs, the streams, been using commercial networks and commercially available hardware, routers, cameras, lidars, and then partnering with this work machines OEMs who are manufacturing the machines and experimenting with these systems on their machines with the intent that if it works well enough, they would be willing to kind of integrate these solutions into their machines. I guess we kind of got the idea of already what kind of industry we're talking about. So the various kinds of sectors here: agriculture, armored vehicles, earth-moving, forestry, logistics, many others, all on their own sort of small, but when you start summing up all these sectors, there is millions of units kind of flowing out onto the market every year. And because these things are there for a while, that you don't switch an excavator as often as you switch a mobile phone. So there is tens of millions of potential aftermarket targets that you can install your stuff on. And this is very important from the perspective of trying to make a business out of this. There is some other companies doing similar things. This is not a very exhaustive list, but just a couple of examples. On automotive side, on the remote driving, there is this basic low latency video vehicle controls. Then when you start going to the work machine side, you start having to deal with the boom, with the tools, and exactly the problem that sometimes you need to bump into things on purpose, sometimes not. And these have been pretty much based on the manufacturer's own designs and their own implementations, and there's a couple of companies who have tried to do something in that space. But then on top of that, what has been already out there on the market, we're kind of providing some extra, let's call it the secret sauce of the project. So help in detecting the work targets, help in aiming, so how to hit the targets that you want accurately, fast, fusing information from various sensors. Some of them might be on booms, might be moving with respect to the others. And then kind of crucially providing this information not as a huge array of screens or list of numbers, but some kind of augmented or mixed reality style visualizations that are intuitive and easy to grasp. I've been considering as a strategy to get to the market. So this is clearly, these slides are based on our pitch deck that we showed to the investors. At least the terminology is from there. So we've been looking at a couple of select manufacturers that we try to make kind of a deeper partnership with, trying to do custom solutions on top of the software and algorithms that we have right now, and start off with those, and then to use this information or experience gained from this to develop kind of a product of our own that could be then sold kind of separately and especially scalably. So not a custom solution for a specific vehicle, but something that can be applied to many use cases. But we have to start from somewhere, and we have a few use cases here now which are very actually kind of from the research perspective, you could say even trivial, but still something that isn't really commonly available on the market. So if we talk about low latency streaming on kind of local robust networks, because many industries have a very different understanding of low latency. So in some broadcasting cases, this might be some seconds, but in operating mobile machines, we're talking about 50 milliseconds, and then they're already starting to complain. And so this is something to start off with, but in the longer term, One of the options is to go for this kind of a solution that you call it remote operation as a service. So basically, monthly fee, we bring the hardware, we bring the connectivity, we bring the software, install, support it, and then your machine becomes remote operable. But let's say this is still a little bit down the line, so it's not launching tomorrow yet. Then this is usually the slide that I leave there as a summary for the end, but because for once I have more than 3 minutes to give this pitch, so we'll keep going. Except the only relevant bit of information here is that commercial activity is from Q4 2022, and it's basically, well, right about now. So we're kind of looking into actually starting to sell things with our few OEM partners. So far, we've been borrowing the Avant that was shown on the also in the previous presentation, and doing demonstrations on that one. We also have a demo with that setup today, unless it has fallen apart while I'm presenting here. But then on the roadmap, also referring to the previous presentation, there is a electrical wheel loader on its way to the university any day now, I guess, which we'll kind of deck out with a bit more hardware and computing power to be used as a kind of a prototyping platform. Then, as a kind of a parallel track or a side track to this work machine industry specific projects, we've been also working on kind of surprisingly nuclear fusion, but there's a kind of a link here, so doesn't come completely out of the blue. So in many cases, when you're dealing with nuclear stuff, you don't want to go there yourself, you want to send a robot. And the remote maintenance operations of this upcoming nuclear fusion reactor that they're building in France, they are very similar to what you would have to do using work machines and kind of everyday maintenance issues. So there we've been working on research project to provide millimeter level guidance for robotic manipulators. And then now the system is kind of mature enough that it can actually be kind of converted into production quality software. And this is something that the university particularly doesn't have much interest in. So this is kind of a good thing for a upcoming startup company that knows how to do safety critical software. Just a few more words about what we've been doing on this fusion front, because some of the work machine project might be kind of familiar to some of the audience, but this probably hasn't come up so much. So the idea there is that we identify targets with very high precision requirements or accuracy requirements, and have ended up doing it with retroreflecting markers, because when you have control over the environment, you can mark them and extract their position very accurately. So we've been dealing with the robot camera calibration, designing marker objects that can be attached in conditions in which the fusion happens, so high temperature, vacuum. Then doing camera-based measurement, figuring out where those markers are, and then leading to target pose estimation. So you could also call it a kind of a visual surveying, except we have very much control over the whole process, and our requirement for the precision is quite high. So I've been designing different kind of marker configurations, how to attach these things, how they would survive in these conditions when they're faced with the plasma from the fusion reactor. They've been creating software libraries, graphical user interfaces to help the operator to operate in these conditions, and will continue developing these things further, especially on the quality side, so that it's not just a research prototype, but actually something that you can take into production. And then we started thinking, okay, how to use this stuff outside of fusion. Of course, retroreflective markers as a tracking thing. If you come from the creative industries, you know it from the motion capture. That's also where we know it from. But it can also be used for tracking any sort of targets in very difficult environmental and lighting conditions, because it doesn't rely so much on the environmental lighting and so forth. Then we can also do on-the-fly calibration of cameras and robotic manipulators. If, for instance, if you have to change your tools in the middle of the operation. And we can do very fast measurements with very high accuracy. And the idea here was that we grabbed that thing from motion capture and virtual augmented reality. We brought it over to be applied in the remote maintenance for fusion reactors, and then brought the technology back again out of fusion and started applying it for remotely controlled heavy mobile machines. And so in that segment, you could think of some cases like container tracking, swapping tools. If you have an excavator going from a bucket to a drill, backing into a trailer, especially nowadays, charging stations for many electrical vehicles, which preferably would do it on their own and not by an operator. So this concept of utilizing these technologies that were kind of refined for the fusion environment, this got us the Fusion for Energy Technology Transfer Award this year. Details on the website, but basically by applying technology that we developed for the fusion reactor maintenance on a columnar reach stacker, as can be seen on the image, they were convinced that we are onto something and should be awarded for our efforts. Yes, and this is kind of meant as an encouragement to further commercialize this technology. Basically, this is what I had to say about particularly the Miro project. The curious thing about this is that the further we go in the project, the less we want to tell anything, because we want to patent, trade secret, we want to sell it and not tell anyone. But I thought, like during the project, we have been traveling various exhibitions and places where gathering information. Just landed yesterday from Germany from a work machine exhibition. So I have a few slides in the end, just kind of latest industry developments, what cool things did we see while going around, looking at what has been happening in the work machine industry and what has been happening in the automotive, because they are not the same, but sort of similar to the work machine industry in some ways. So it's kind of a nice target where you can go and steal stuff from. So there is this concept exists about having purely unmanned vehicles, but they are really quite concepts. So we, in that whole thing and the whole 1 week exhibition, we found one single excavator or kind of a heavy duty work machine that was actually meant to be unmanned completely, which is this electric excavator in the picture. And the rest were basically kind of plastic 3D printed maybe prototype in a glass box, saying that, oh, this is sometime in the future. So the kind of the industry is not there yet. Like they are not, they don't have the kind of solutions for driving purely unmanned vehicles. They could be autonomous, they could be remote controlled or something in between, but don't seem to be really existing yet. But some more, let's say, application-oriented or applicable things we're seeing that are, you could say, kind of are unmanned by retrofitting. So you have a old-fashioned thingy with a cabin in it, and then you bolt on a set of sensors. So in these pictures, both on top on the roof, you see this kind of a box bulging with sensors, sliders pointing in different directions, and this is able to either make it remote controllable or remotely drivable or autonomous. Sorry. And these are kind of commercially available already, so you could basically go to these companies and, okay, I'll have one, and they will sell it to you. Then a few guys are doing teleoperation stations. So on the first image is that I guess the furthest along is Caterpillar. They have been apparently doing this already for 10 years, but nobody has seemed to hear about it before. So they actually have launched, like, commercially a fully functioning teleoperation service for a certain set of their excavators and bulldozers. Then in the middle there is another big OEM, but it's still a concept. And on the last image is basically a startup that started 2 months ago. So competition basically with their own remote control station. So these things kind of they exist, but not in let's say frequent use yet. And one kind of a cool thing that I saw was a product called Rod Radar, which is a specifically designed excavator bucket that can detect using ground penetrating radar. It can detect if you're about to dig into a water pipe or electrical line, and that's kind of a nice thing. Cost a bit though. Then just a few more notes about what was happening in the automotive side or automotive sensor side. I'm not touching electrical versus hydrogen or anything like this, but some concepts from there which are kind of on the surface right now is that in the beginning they were like littering computers all over the car, called the zonal architecture. Now they are really trying to escape from that, because then they realize that they have to maintain all the computers around the car. And they want the one big one. And everything should be software defined so that they can refine, update the vehicle after the fact. Then that there is a lot of data going around, cameras, sensors, everything. It really matters how this is transmitted. And solid state lidars are really desirable in that market. And especially from the perspective of, if you're talking about imaging, visual technologies, there is a very specific segment of cameras, which is automotive sensors, where they're dealing with such things as flickering LED lights, because everything is nowadays with the tail lights and all. It's LEDs. They run really ridiculously high dynamic range compared to, well, everybody else. And everybody in the industry has agreed that any camera that points forward has to be 8 megapixels, because then you can see enough pixels so that your AI can identify a car from 300 meters away. And everybody is now doing 8 megapixel sensors. And if you want to see around you, it's a 3 megapixel sensor. And it's almost kind of funny how everybody has really converged on the exact same specification. And on the LiDAR side, automotive cares about one thing. After they have reached their target at 300 meters of operating range on a laser scanner, cost, and it needs to be really cheap, and they are not yet. And everybody is trying to figure out how to make a cheaper LiDAR, and that's the focus there. Some new developments. If you know anything about LiDAR technology, these are kind of cool. If you don't, you probably can ignore those bullets. But different ways of how to scan the environment with the lasers, how to get instant velocity using the Doppler effect, and doing LiDAR scanning in different spectrums, for instance, shortwave, infrared. And my last slide of the presentation. It turns out that camera interfaces are really hard. Every single camera sensor that the automotive industry is using plugs in with a MIPI connector. It can last 30 centimeters before it dies out of signal. So then they started using extension cords, 2 competing standards, which are not actually standards, they're proprietary. And to help solve this issue, 3 new standards were recently introduced. So yes, they are still very difficult. But this ends my quick view into what's happening on automotive and work machines.
Okay, thank you very much. Questions?
Hi, you mentioned before about LiDAR scans in the automotive. Do you know what path the trace takes? Is it the traditional zigzag, or this has been developed into something that is a better space filling curve in terms of isotropy? Let's say the X and the Y are equally represented over time delta, let's say.
Yeah, it almost depends on the manufacturer. So pretty much everybody does their own thing. Like some of them are steerable, some of them are fixed, some of them are going in a comb structure, some of them are doing the zigzag.
Or Lisa Zhu, like a kind of Lisa Zhu figure. You know Lisa Zhu, the...
Yeah, there's like, probably you can find a LiDAR with any sort of a pattern right now, because everybody is trying to optimize and come up with their own cool idea.
Okay.
So there's no fixed.
And I guess the question there is how fast it reacts to changes in the thing that in front of you. So, milliseconds matter, microseconds.
Yeah, typically they don't really even discuss the latencies. I presume this is a kind of a solved thing. That it's really a matter of range and cost, and all the technicalities have kind of been solved otherwise, at least for the automotive.
And is it also a matter of power consumption of the device? No, probably.
I think they are not very power hungry, as it seems. At least, also hasn't been an issue raised about the power consumption.
Okay. Is there a case where if you had multiple cars, let's say, using the same technology, because at some point you're using a laser in some sort of spectrum wavelength, that there is interference between different objects moving in the same area? The same.
Most of the the most advanced LiDAR technologies, they are somehow coded that they kind of understand which is their own light and which is coming from somewhere else.
How is this done?
Various kinds of things. We can chat more after.
Yeah, it turns to conversation, which you are very welcome to have with the buckets when we get it. Other questions?